definitely soil moisture will impact agriculture, food, water, drinking water, aquatic life, and so it's definitely an important variable. But our ability to predict the changes in the soil moisture is actually more important, because if we can forecast that this is what is going to happen to the soil moisture in, say, the next future, near future, or something like that, then it's going to be important. But how do we do that prediction? It's a cause effect relationship. What are we doing now that is going to cause a kind of effect in the future? And this is where causality analysis comes.
Hi there, welcome to the Green Living Chats. I'm your host David with EcoAmed Solutions. Today we bring you a special episode, Research Stories. This is where we have chats with researchers in diverse disciplines of the environment, talking about their researches and how they can be applied in the industry. So we'll pick bits from it and use it for awareness campaign. In the last episode, we talked about the benefits of remote sensing, variables, assumptions, and satellites used in remote sensing for predictions. I recommend that you check this episode out before we jump into today's episode. In today's episode, we are talking about human influence in CO2 generations, as well as the use of soil moisture to forecast heat waves, and also about the gap between research and policy making. Here we go. So, if I understand you very well, you have spoken about how first you started from where we have stations down on Earth, and the distances
Mhm.
between the stations do not make data collection very efficient. So now we are
Yeah,
trying to incorporate the use of satellites that can occupy or get a wider scope. And
yeah,
then, even with this, we have to use models to do these predictions. And in feeding the models, we have to use certain variables. And even in using the
mhm,
variables, we have to use some assumptions, right?
yeah,
What
yeah.
goes into these assumptions? And if we have been using assumptions over the years, how effective have they been? And of course, definitely we need to improve upon the technology we're using. So now we're
Yeah,
going to, especially with your thesis, you decided to put aside some of these assumptions and then use the
yeah.
real thing. So what are you replacing it with? I just want you to just give some
Okay.
specifics
All
on
right.
this.
All right. So let me. Okay. So let me tackle one of the technical parts.
Okay.
So when we are retrieving land surface temperature, in 2009, um, mm, a guy called Thomas Holmes developed a model, a very simple model to retrieve land surface temperature information from satellite datasets. Now, uh, this was kind of like a first step,
Yeah.
and Thomas is a very Thomas is a very, very careful guy, super careful guy, and he likes to do things in steps. And so what Thomas did was that when the satellite scans on the land, there are some times that it will scan on a place that will have both land and water. Now the signals that are, because like I said, everything is bringing out signals, right? So the energy that you are emitting is different from the energy that I am emitting. But of course, because we are both humans, we will have a similar signature. However, the signature that you are given, the signal that you are given, is very different from the signal that a water body somewhere will give off. And so it's the same thing between the land and the water. For instance, if you can, anyone can try this typical experiment that on a typical day in the afternoon, go to a place where there is both land and water. Put a thermometer on the land in the land and measure the temperature, and put it in the water and measure the temperature, and you find out that they are different.
Mm.
And in the same way, at night, go to the same place and measure their temperature, and you realize that they are also very, very different. And so, because of that, uh, we have to sort of separate the signals coming from water from the land. So what Thomas did was that Thomas Thomas sort of assumed that there is no water on the land
Okay.
and only focused on the land signals because he wanted to build a very robust and reliable method. And then he came up with this model that can retrieve land surface temperature from the satellite imageries. But what Thomas, and he actually made this comment, Thomas commented in the paper that if the amount of water within a satellite imagery or a satellite point is more than, if the amount of water is, or the fraction of the water within a particular, let me say, pixel,
Mm-hmm.
um, if it's more than 4%, then you have some sort of biases, the quality will reduce. So this is what Thomas said. And so reading what Thomas had said 10 years ago, um, I realized that, okay, if this is what Thomas said, can we try to find out exactly if we can sort of find a way to, whenever we have both land and water in the
Yeah.
pixel, let's find a way to separate those signals and not sort of do away with the water, but still include the water and somehow separate the signal of the water from the signal of the land and use it for a more uh, robust method. And so this is what I did with a student of Thomas, who was my co-supervisor for my thesis. And so because he had worked with Thomas, he knew how Thomas
Yeah.
taught and everything. And so uh, I worked with him on this particular problem, and we quantified the impact of water signals on on the land surface temperature. So we were able to get higher quality
Yes.
land surface temperature
Mm.
data sets. And land surface temperature is very, very important because you can actually use it to predict droughts and floods. Uh, uh, my co-supervisor did a study of Australia for the Australian Meteorology Agency, where he used land surface temperature to model the flooding that happened in
Mm.
Australia, and it was very, very accurate. So even just with land surface temperature information alone, you can actually do a lot of things with it. And human activities definitely
Yes.
impact land surface temperatures. And so uh, this is what I did. The assumption of Thomas of not considering water signals, I considered the water signals in it. And in the same way, in the causality tool, for instance, um, I also made there was an assumption that a long time causalities don't change,
Okay.
but that is not true because you find a time when there will be a time when soil moisture will impact the precipitation more than precipitation is impacting soil moisture, and there will be a time when it will be reversed. And this is something that my teacher did not consider in his model. So I we after talking, we sort of put in that assumption, say, okay, no, there will be a time varying causality. And so if you look at my page, for instance, there's one paper called time varying causality. And this is the model that we came up with.
Mm.
And we already used it to investigate uh, the Sahel over Africa, to investigate the changes in rainfall over Africa, over Western Africa, Western and Central Africa, the Sahelian belt. The Sahelian belt is one of the most important places in the world for climate studies
Mm.
because any changes there will impact the
The
world.
world.
And so because of, there's a desert there, and then there's a sort of a middle ground there, and then there's the Congo Basin, which is a very forested area. So you have sort of different
Yeah.
climate conditions, and because of their different gradients, they really impact the world.
Mm.
And so we found out that the rainfall over the region has stabilized.
Okay.
It stabilized over the last couple of years. It stabilized, and and so we wanted to find out why was it stabilizing, and we realized that this was actually because of um, the ocean, the temperature of the ocean. And so we used this causality tool that I developed to quantify how much the ocean is actually impacting this stabilization.
Mm.
And it was a very nice paper that I think people are beginning to read, and we hope to get more responses from it. Yeah, so these are, and of course, yeah, we found out that it changes over time. it changes over time. That kind of relationship changes over time, and so if we had used the original method, we wouldn't find this.
Yes.
But since now we're using the updated method, we can find it. Yeah. So
It keeps getting interesting.
yeah.
Right. So we're going to get into your results in packages, let's say. And
Okay.
I'll just try to get your thoughts in from different directions. So let me come from
Okay.
the application direction, right? So I know
All
that
right.
you have assessed and you have analyzed a lot of data over a long
Yeah.
period. So what
Yeah.
would you like to say? What are the differences and what are the changes that you're seeing um, over time when it comes to, let's say, temperature? I don't know
Mm,
whether we can consider the world as a whole, we can consider a particular confined place, let's say China, or let's say
yeah.
Africa, some parts of Africa. What are
Yeah.
the changes that you have seen? And in your, let's say, in terms of assumption, what can you say are impacting these changes, especially when it comes to temperature
Okay.
and soil moisture
All right.
content?
Okay. So this is definitely not a very straightforward
I know.
thing to reply, because there is a significant debate going on in the science world, especially in climate studies. In the Some people think that you know there is nothing happening, and some people think that no, there is something happening. But at least I am speaking from the point of satellite technology and what the satellites are showing us.
Yes.
So yeah, and the reason is that there are also some people who are using computer models. So this is what I am calling the land models. So I work both with land models and with satellite data sets, because they both have advantages and we can learn from them.
Hmm.
Uh, so what has been happening is that, of course, we are seeing an increase. We are seeing a significant increase, and one of the significant impacts is CO2, carbon dioxide. I'm currently working on a paper, which is I'm looking at the structure between the causal structure between temperature and CO2, um, from 1961 to 2100.
Hmm.
So from the past through the present into the future. So I am looking at I'm analyzing that, and there's some pretty exciting um, findings that we've had. And certainly temperature has a consistently increasing um, uh, relationship with CO2. One of the reasons that even though the world has done so well, especially China and India, to reduce CO2 output, uh, um, CO2 has a very long lifespan in the atmosphere. And so, you put CO2 in here today, it could last from 50 to 100 years, you know. So even after you stop emitting CO2, you will still have its impact. And there's a recent paper that has sort of mentioned this. For instance, during the pandemic, there was a significant reduction in the production of CO2. However, the impact of CO2 was still
It's
going
already
on.
there.
And yeah, so it's like, okay, what's happening? Yeah, it's not something that we just don't stop today and say, okay, tomorrow let's go back. It's actually something we have to handle for a long period of time. And so what is happening with this temperature? Certainly they are increasing. But I think that what people don't understand is that usually when we talk about temperature increases, and you hear scientists say this, they're very careful with their words. They say global temperature. And when a scientist says global temperature, it means that they found a way to calculate, like, take the whole of the globe and to calculate sort of one temperature for the globe. But that is a very difficult and complex thing to do, because
Exactly.
it's happening differently over different areas. So some places are going colder and some places are getting hotter.
Water.
And what you actually find is that summers are getting hotter and winters are getting colder. So the idea of climate change and global warming is that global warming is affecting the peaks. It's increasing the extremities. So you have the cold getting colder and the hot getting hotter, and this is what is happening there. And so when we talk about this temperature change, this is where time varying characteristics should be in our minds. That we have these time varying characteristics. But then on the whole, sort of the long-term trend, then we see a consistent increase in. There's been a sort of a leveling up for a while, called the hiatus. So there's a whole group called the hiatus group that they are focusing on the leveling and saying, no, nothing is happening because it's leveled off. But the satellite data sets suggest that there is a significant increase over there. And so, for instance, in the future data sets that I'm using, there are 4 different scenarios, and the 4 different scenarios vary. They vary. First scenario is, what if we stop emitting CO2 today? What is going to happen to the temperature? So that is the first scenario. Second scenario is, okay, we are producing a little and adding some mitigation methods. Okay. Third scenario is, okay, we still produce, but we are still a bit careful about it. So kind of different levels. And then the fourth scenario is like, we don't care about it. We just continue producing in mass. So there are different scenarios. We call them the scenarios of climate scenarios. And so what we do is that I am investigating how temperature and the CO2, how they vary in these different scenarios. So if we stop emitting CO2, how will the climate look like by the next 100 years?
Okay.
And if we continue, if we don't care about it, how will the climate look like in the next 100 years? And the results are very exciting. There's a lot of forecasting involved, meaning that we have to improve our cause effect models. And so this is where the second part of my work becomes extremely important. So over here, I've combined both the first part and my second part and studying. So the climate is actually changing, and the impacts are different in various areas. There's a paper that we published that we found out that, for instance, that frequencies are increasing in some places, and in those places where the frequencies of, say, frequencies of floods or droughts are increasing. So there's more droughts taking place, but the magnitude is decreased. So there's more of them, but then in smaller magnitude. And in some areas, the frequencies have reduced, but the magnitudes have increased. So then there is this kind of inverse relationship between them. And so I'm always careful when I'm answering these questions, because different areas are experiencing it in different ways. But then it is clear from the data and from what we observe around us that we are having some significant changes, and we have to find a way to deal with it. And this is an area I have been working with the community on since 2013, and it's definitely it's an exciting area that you have to be careful not to get carried away.
Yeah.
Yeah. So yeah, but also that we are finding that soil moisture is there's places where soil moisture is significantly reducing and places where soil moisture is significantly increasing. And especially with the places where soil moisture is significantly reducing, we're getting more droughts and heat wave events happening. So these are some of the results that we came up with. I supervised the master students where we did this. We looked at how soil moisture is impacting heat waves over China. And we had a very, very strong and interesting relationship over there, which means that we can use soil moisture to forecast these heat waves. When we know the state of the soil moisture now, we can actually forecast the heat waves. And this forecasting idea is one of the things that I'll be working on in the next couple of years. Yeah.
This is brilliant. I just want to get your thoughts again on this area. Listening to what you're saying, I think that we can rely on remote sensing data. Am I right?
Yep.
We can rely on that.
We can rely on. Yeah.
So would you like to clearly tell us what is the correlation between this data that your team and other teams who are doing related things, how are they correlating with policymakers and the industry and people who can make changes? Because if we have the data available and it's predicting that these things are happening, and obviously we are seeing these things happening, in real
Yeah.
life. And if you ask people who have
Yeah.
lived over the decades, they tell you that we have seen
Yeah.
changes. The data is
Yeah.
also
Things
telling
have
us
changed.
they
Yeah.
changes. So what is the
Yeah.
correlation between the research teams, and is it working very well, and how are they responding?
Yeah. So there is definitely a lot of collaboration going on there between governments of different places and the scientific community. Um, but I think that yeah, we definitely need more ways to talk about these things. Um, and one of the guys who really inspired me, his name is Jason Blackstock, and I met him in 2013. Uh, he's a crazy guy. He got his bachelor's in English literature and his master's in physics and PhD in physics. Um, that's why I say it's crazy. And and then he went back and did a master's in public speaking, public address and
Wow.
administration. Um, but he's a very nice guy, and what Jason does is that he's a scientist who takes the result of the scientific community and talks to um, government and policymakers about the result, because we have to communicate with them, but we can't communicate technical things.
Yes.
And so every couple of years, the Intergovernmental Panel for Climate Change, the IPCC, they release a document, and this document, it talks about the status of the climate. And so they have it in different difficulties and technicalities, but they have a document where they release it for policymakers who may not know the science very well. And the wonderful thing about the IPCC is that the IPCC collects almost all existing research.
Mm.
They put so they collect all this research and put them together. And and the guy who introduced me to my supervisor, the one I said I met in
Yeah.
Beijing, he's actually one of the people who have been in at the leadership of IPCC. He's actually one of the co-authors on my causality paper. He is and so he's very very aware of these things. And when we talk with him, we have to communicate with him. So we present these documents to the policymakers as to whether they will, they'll go according to
Yes.
these things. It's another problem. I'll give you an example. There was something called the Kyoto Protocol, which was designed to help countries manage their carbon emission. This was done quite a while ago. So every country was given a portion, how much CO2 you can release. They calculate a lot of things, the people and the population, so your needs and everything, because some people really do need to produce the carbon. um, yeah.
They've actually
So
paid
what
to
happened was,
release.
yeah, yeah. So exactly, I'm actually coming to that point. What happened was that there were some developed countries who would, when they are reaching their quota, so they will probably come to country A will come to say Ghana and say, hey Ghana, you are definitely not going to meet your quota. So we are going to buy your quota and so that we can keep producing. And so this is what some of the countries were doing.
Mm-hmm.
Of course, along the line, some countries felt like no, we are being restricted too much, so they quit. Um, and so this is what at the policy level they're trying to do. They're coming up with ways, but countries would have to agree, and sometimes
Yes.
they don't agree. Sometimes they do agree. Sometimes some people fall out of the agreement. China, for instance, was doing very well. So what China was doing was that um, uh, China would there was some time that China would sort of shut off their industries,
Oh.
maybe in Beijing or something like
Mm-hmm.
that. Yeah, when they're sort of approaching their quota, they'll shut it off, so that they would, and it was really doing well. And as well as the greening. There was a recent paper that China and India are leading the world in greening.
Oh.
This is something that is very good. It's good for the soil moisture community. We get to see how this greening impacts this thing. In the paper that we published over the Sahel, if you see the title, it's greening and leveling of precipitation. So both the greening and precipitation have leveled over the Sahel. But of course, we also have some underdeveloped countries who are complaining that, hey, we never polluted enough to develop, so we have to be given the chance to to pollute. And so the policy, at the policy making level, it's a very tricky thing. And as scientists, what we can do is to communicate in the language that policymakers can understand. Sometimes there is good communication. Sometimes it's not very much, but the remote sensing technologies help us to sort of see some uncertainties, because in the past they were saying, no, you're just using computer models, and computer models can be, they can be changed, they can be tweaked here and there. So we want observational results, and the satellite observations help us to get real-time observational results and say, okay, now satellite observations are saying this, we have to pay attention to it. So let's hope that it gets better.
Yes.
The science community has to communicate.
Thank you for listening to today's episode. Next episode is up this and every other Sunday on Apple Podcasts, Spotify, and any other podcast platform. In the final part of the series, we are talking about climate change predictions using remote sensing and how can we reduce CO2 emissions. Visit our website at www.ecoametsolutions.com for details. See you again on the next episode. Until then, live green.